Hi everyone, welcome to this week's episode of AppSecEngineer. Today we're going to be talking about the 7 deadly sins of container security. Now, container security has been a hot topic in the industry for a while now, especially because
We're also
a lot of
seeing a
folks are
lot
now
of
starting to
use
use
of
container orchestration technologies like Kubernetes or Mesos and so on and so forth. And container security is becoming more and more important aspect of the enterprise security space, so to speak. Right, so this is a video where I'm going to be talking about a few critical security mistakes and defense possibilities with container security. So before we get started, just remember this, right? Now, whatever we are talking about is not necessarily only when you're running containers as, on a test machine or on a developer machine with the Docker CLI. This also applies to orchestration systems. So the mistakes you make when you're running containers uh, individually can also be made when you're running containers as part of the same kind of mistakes can also be made when you're using things like Kubernetes, Mesos, ECS, Fargate, so on and so forth. So the mistakes that you make in terms of container security deployments when you're running them individually can also make their way into the way you run these containers in container orchestration systems. Of course, depending upon the way the apps are vulnerable. So a lot of these depend on app vulnerabilities, right? So let us say your Ruby app has a deserialization flaw that can allow somebody remote code execution. Then you might see that these attacks may become worse. So a lot of what the container threat model really is about the application itself. So if your application is vulnerable, chances are that a vulnerability in the way you're running some of these containers can exacerbate or not be as bad, right? The other thing that I want to talk about in today's video is that a lot of these sins that I'm going to be talking about, I'm going to be talking about 7 specific ways or 7 specific sins, and a lot of these sins are what are prescribed by a lot of maintainers and folks running containers in the Docker Hub and so on, because you might need to use some of this behavior for some type of containers, but there's still security risks. So I just want you to understand that before we get into the video. It's not that you should never use any of this. It's just that it's bad from a specific perspective, and this could get worse depending upon how you run your container, what kind of vulnerabilities are in those applications that you're running in the containerized space. Right, so that's pretty much what it is. So before you start with this, you need to have a basic understanding of what Docker is and what containers are, so you can follow along a lot better in terms of this. Just a reminder, these are not the only type of security mistakes or security issues you could find with containerized deployments. There are many more, obviously, but I believe that these are some of the most common ways that people would make mistakes when they're running containers, especially from a security standpoint. So let's get started with our first deadly sin, which is running as UID 0 or running a container as root. Right? Now, this is especially bad simply because if you are running the container as root, the container interacts with the kernel, the Linux kernel or the operating system kernel that you're using as root, and the container can now start using resources shared with it from a root user standpoint. So as a result, the container can break out. There are certain things that the container can do to expand privileges to outside of the containerized process to the host operating system as well, right? So let's look at an example of what you can do when a container is running as root. So let's take our example first. So here I have a machine. I have a VM set up on the cloud called Docker Test. I'm going to be using this for demonstrating most of what we're going to be talking about today, right? So let's say that I am the root user. So if I do ID, I'm obviously the root user of the host machine, right? Now in this case, I'm on the host machine and I'm the root user of said host machine. So what I'm going to do now is create a file. So let's say I'm going to do echo this is a secret, and I'm going to write this to secret.txt2 /root/secret.txt, right? Now this obviously is a file that should be read by or accessible to UID 0 or the root user of that system. So if on the host machine I change my privileges to v45 and I try to access cat slash or secret.txt, you will see that I get a permission denied. In fact, even if I just do an LSAL on the root directory, I'm not going to be able to read anything on the root directory because I'm not root user, right? Now, however, let me just change this up a little bit, right? So let's just add v45 user to the Docker group, right? Now Docker runs as a service account on the Linux box, and you can add different users who can access the Docker daemon or run Docker containers. So let's do that. Let's configure access to v45 to run Docker containers. The next sin is especially egregious as well. This is essentially the sin exposing the Docker socket to a container. Now the Docker socket is really how the container gets spawned. So it's typically, the Docker socket is running on var run docker.sock in most Linux machines. And in this case, what happens is if you expose the Docker socket to another container, so let us say you spawn an Ubuntu container from your host, and you expose the Docker socket to the Ubuntu container, now that container will be able to spawn Docker containers from within itself. Right? Ideally, you don't want that happening. Especially, you don't want an attacker being able to gain access to that functionality. Imagine if you're running an application, let's say a Ruby application on an Ubuntu container, and you have exposed the Docker socket because you want that application to be able to run its own or spawn its own set of containers. Now, if the attacker gets access to that functionality, or if the attacker is able to escalate privileges beyond just the Ruby application, gain access to the backend operating system through a command injection or whatever, the attacker is now going to be able to spawn containers because you have exposed your Docker socket to that particular vulnerable container that you are running, right? So that's something that is really, really bad. So let's look at this with an example. So let's take, I'm actually going to kill both my panes here. So I'm going to be running this with tmux just to simplify the whole process. So I'm going to split the panes horizontally. On the first pane, I'm going to run my Ubuntu container. And on the second, I'm going to try and see how you can use the Docker socket to be able to perform the attack more completely, right? So let me just move over to the top pane, and you can see my cursor here. So here, what I'm going to do is run an Ubuntu container with access to socket privileges, right? So I'm going to run docker run it. Of course, I'm going to volume mount var run docker.sock, which is the Docker socket, to the same path on the Ubuntu container. So I'm going to run Ubuntu, let's say I'm going to run 16.04, and it's running. It should be running soon, and you can see that now I have access to the Ubuntu shell environment. So if you see now, what I can do potentially is completely gain access or use this Docker sock to be able to run my own containers from inside this. So what I'm doing now, if you see here, is that I'm in the Ubuntu container. So if I do a cat etc hostname, you'll see that it's the Ubuntu container that's running. Of course, this is running as root. I'm not. It's not a container that's running with non-root privileges. Now, let's say I want to spawn containers from inside this container. What I can do is install Docker. So what I'm going to do is, now is install Docker on the running container. So I'm going to first install apt install -y wget, and then I'm going to use the wget command to pull the container down, pull Docker binary down and install Docker on the container environment. So let's see that happens. So I'm going to first install the wget library to be able to pull down the Docker install binary and install Docker on the container. Now you can see that the Docker CLI and Docker Compose has now been installed on the Docker container which I'm running, which is an Ubuntu container. So let me just clear when I clear this and do Docker images, you'll see that there is a bunch of Docker images that are running on that particular Docker socket. Now, since the Docker socket has now been exposed to this particular container, the container is able to actually get a full view of all the containers that are running on my host operating system. Right? And you can see why that's really dangerous, because from inside a container, I can pretty much control the life cycle of any container that's running on the host operating system. So now remember, I'm now on the Ubuntu guest container, so to speak. So I'm going to be able to pretty much spawn and run my own containers if I want to. So if I do docker run -it, run another Ubuntu container from inside my the already Ubuntu container, I can actually run this. So I can do docker right Ubuntu 16.04 bin bash. So what we've done now so far is actually volume exposed the Docker socket to a particular container, and we've installed Docker on that running container, and you can see that at this point in time, that container now can virtually control all the communications or virtually control my host access to the Docker daemon or the Docker CLI, right? So if I do Docker PS, you'll actually see that not only do I get a full runtime perspective of the daemon on the host, I can also actually stop machine. So let's say I want to stop this particular running Docker, which is, let's say, another running container on my host machine. All I have to do is say Docker stop, copy over this ID, and it would stop that. So if I do docker ps, now remember, I'm in the container context, so you can see the host name is not on my main host machine, it's actually inside a running Docker container, and you can see that I can stop containers from inside here. Worse, I can actually perform a full container breakout, right? So let's look at the really bad things I can do from here. So let's say I do docker run -it. Now in this, what I'm gonna do here is essentially run another Ubuntu container, except that in this, from within a container, of course. So you can see that I'm running it from within a running container. And in this case, what I'm going to do is I'm going to volume expose the entire slash directory to a /host fs directory on my container. So I'm going to run an Ubuntu container, and I'm going to run bin bash on the Ubuntu container. So here what I'm doing is, from inside my container, I am running another container, because now I have the Docker socket exposed, so I can run container spawn from the host itself. So I can spawn containers on the host as if I'm the host machine. And in this case, what I'm doing is volume exposing the slash directory to the /host fs directory. And let's see what happens here. Now here I'm inside another container. This was the container that was spawned from inside this particular container. So it is a second, maybe you could call it a nested container, right? Now, apart from this, the real dangerous part comes in when I actually look at my host fs directory, right? Now, when I look at my host fs directory, you can actually see that I have mounted my entire host /path on this host fs directory. And if you look at the cat etc cat host fs etc host name, you'll see that I have actually broken out to the host, and my entire host's file system is now accessible to me. So that secret file that I had created previously, again, I'm sorry about that, host fs root, you can see that now I'm able to gain access to the complete host operating system from this point on, all because you exposed Docker socket. Now you would be thinking, how is this very different from the previous attack that we showed? The previous attack was different in that you were running a container as UID 0. Now in this case, what we did was mount the Docker socket. Now the Docker socket is what enables the Docker container to communicate with the daemon, right? And if you mount that into another container, you can pretty much control the entire container runtime on the host. Now, you would probably be thinking, why would somebody do something as stupid as that? Now, this is more common than you think. So let us say you have a CI/CD service. Let's say you're running Jenkins, and you want Jenkins to spawn other containers. So let's say you're running Jenkins as a container itself, and you want Jenkins to spawn other containers from inside a container. That's when you would need something like that, or some other process from within a container where you need to spawn other containers. That's when you need to mount the Docker socket file, right? And even though that may be legitimate use case, it's really dangerous, because let's say that service was compromised by some attacker. Now the attacker could be literally running anything on your environment. So let's say the attacker could run something like a crypto miner or something like that. From there, the attacker could use or the attacker could bring down your services. So this is pretty dangerous based on how you see it. Again, in many cases, this is required functionality. For instance, let's say you're running something like Portainer or whatever. A lot of guides would tell you that, hey, just volume mount Docker sock and get started with it. But you must understand that it's really dangerous, because if some attacker is able to compromise that application, that attacker now gets a massive pivot into your entire environment. The next deadly sin that we're going to be talking about is running a container with the -- privileged flag. Now, the -- privileged flag is a security specific one. Now, by default, when you use Docker, and Docker, just to clarify, Docker is not the only container runtime out there. You can use Kata, you can use different types of container runtimes. Docker just happens to be the most popular. Now, when you're running Docker, typically Docker by default blocks around 44 out of 300 odd syscalls. Now, a syscall is typically a call that any program makes to the kernel for the kernel to give it or to perform certain actions. Now, if the kernel has filters enabled, or if those actions are disabled, those particular calls may not be made by that program. So let us say a raw socket call or ability to add more privileges to that particular process. These may be considered dangerous security calls. So you might have them blocked, or you might have a SecOp filter or an AppArmor filter to block those particular type of calls. By default, Docker blocks 44 security or risky syscalls from being run when you're running a container. So let's say you're running a standard Docker container, you would see that out of the 300 odd syscalls, about 44 syscalls are blocked by default. However, you have a way of making those syscalls being unblocked, and that's when you run the -- privileged flag, right? So let's look at a demo. So if I run just a simple Docker run IT whatever Ubuntu, in this case, I am running it with those 44 syscalls, whatever dangerous syscalls that Docker has, to be blocked. However, let's say I run it differently. Let's say I run Docker run IT -- privileged Ubuntu bin bash. In this case, you can see a slight difference. What I'm doing here is I'm running that particular container, but I'm running that particular container with full privileges, right? In this case, none of those 300 odd syscalls are blocked by that particular container. So all of the things that the host machine can do, now the container can potentially do, simply because it is running as -- privilege. So all of the syscalls that were allowed to a host machine would be allowed by that particular to that particular container. So in this case, right? So it's running with the -- privilege flag. Now let's see what can happen because of this, right? So what is so bad about running it with -- privilege? So let's look at a different approach to this. What I'm going to do now is not only run the -- privilege, but I'm also going to run the flag for an additional sin that I'm going to be talking about next, which is the -- net is equal to host. So let's say I run Docker run -it, which is going to be running it in interactive mode. I'm going to enable the privileged flag, and I'm also going to say net is equal to host Ubuntu 16.04 bin bash. And when I run that, you'll see something interesting happen. Now you actually see that there is no real container etc host name that's been generated, simply because this process has the same level of privilege as any other process has on the system. So there's no real separation of any sort. You're running it like any other process on the system, and the net host ensures that the host's network is now used by that particular container, right? So not only does the container have all the sys calls unblocked, all the dangerous ones included, the container is also running with the network configuration as the host. So whatever host network configuration or host network ports or services now accessible to the container as well, right? So if I install apt update, now I'm going to install apt update and apt ufw on that particular container image, because I want to be able to see how it works. So I'm going to install apt update, and then I'm going to run apt install -y ufw. This is the firewall package. So it's going to add the firewall package. We're just going to fast forward through the video there. Now remember, I am still inside the container, right? I'm running the process as a container. So one of the things you'll see here is now if I run ufw status, you'll see that the status is active. Even though I'm not installed the firewall or I'm not enabled the firewall on the container, since the container is running with host privileges and the network of the host, I can now, you can see where I'm going with this, disable ufw. Which means that now, even though you are a container process and a firewall has been enabled on the host, you can, if you have sufficient privileges on the Docker container, disable any host service, stop any host service, pretty much do anything with any other host service, depending upon what kind of privileges have been provided. And now if you see ufw status, even though I'm the container, you'll see that the status has been set to inactive. Let's say I exit from the Docker context, go back to my server, go back to the host machine and then run a ufw status, you'll see that it's been set to inactive.